Today what we'll be working on is what's the process of taking an antiderivative of a function, which is basically the reverse process of taking a derivative. So previously, if I gave you f of x, you had to find the derivative f prime of x. Now what I'm going to do is I'm going to give you f prime of x, and you're going to find the function above it, or f of x. Another notation that you'll see is if I give you f of x, and I ask you to take that antiderivative, the function above it, we're going to call it big F of x. So let's say the function is 2x, and I want to find the antiderivative of 2x. So what you need to be thinking about is, okay, what function, if I take the derivative of, will give me 2x as my answer? And that function in this case is x squared. So because if I take the derivative of x squared, I will get to 2x, which is f of x. Okay, but there's actually more than one answer here because I can actually do this. The derivative of x squared plus 1 also gives me 2x. This can be any number. This can be 10. This also gives me a derivative 2x. So really when we take the antiderivative, there's going to be more than one answer. So the antiderivative of 2x is really x squared plus, and this can be any number, so we're going to call that as a constant, we're going to call it c. So there's a whole family of functions that would give you the same derivative. Graphically, the reason why it makes sense is, okay, so here's x squared. Okay, when I ask you to take the derivative of this function, we're talking about the slope here. But slope here is 0, slope here is something positive, etc. But I could do any vertical shift of this graph, so let's say that's x squared plus 1. Notice at the same x coordinate, the slope is the same. So here, you would have a tangent line that has the same slope. And I can make c be a negative number. So at that same x value, you would have the same slope. So there's lots of graphs that would give you the same slope. That's why there's a whole family of functions. Okay. A little bit of a notation. So when I ask you to find the antiderivative, this is the notation that we're going to be using. So the antiderivative of 2x dx is going to be x squared plus c. Okay. This whole piece right here is called an indefinite integral. So when I ask you to find an indefinite integral, you're looking for the antiderivative. Okay, couple things. This piece right here is called an integral sign. That's the operation that's performing the antiderivative process. This whole thing, the function itself, is called the integrand. This piece right here is called your variable of integration. Okay, but the whole thing is called your indefinite integrals. So try these three, see if you can just think about intuitively what you think the antiderivative of these three functions are. Okay? The way to check your answer is if I take the derivative of this, you should get back to this. So how do I take this derivative? You bring down the 5, so the 5s would cancel to be 1, reduce the power by 1, get you to x to the 4th. Antiderivative of the cosine would be sine of x, and if you go backwards, the derivative of the sine is cosine. Makes sense. This one's a little bit trickier, but this would be your antiderivative of x to the negative 3, because if you take this derivative, bring down the negative 2, you get to a 1, reduce the power by 1, gets to x to negative 3.